Hi everybody, it's Mrs. Westmoreland, and in our next class we're going to make s'mores by toasting the marshmallows with Bunsen burners, and we're going to use the s'mores as an analogy for the type of calculations that we are getting ready to learn how to make. So the idea here is that if we had a large bag of marshmallows and we wanted to figure out how many graham crackers and how much chocolate we needed to buy in order to completely use up that bag of marshmallows, what kind of calculations could we do with the information we have? And so we are saying that each one of these things has a unit mass. And so you can think of this like the molar mass that you would find on the periodic table. And in your table you have the molar mass of each one of those substances that we've just sort of assigned them a value. And so the first question asks you to calculate the unit mass of s'more, which we've given a chemical formula. So each substance has been given a chemical symbol, and then the compound of s'more has been given a chemical formula, and therefore each one also has a unit mass, and we can find the unit mass like the molar mass of s'more. So since s'more has two S's, which are the graham cracker mass, we would take 2 times the mass of the graham cracker, plus the mass of the marshmallow, which is the MO, plus 2 times the mass of the RE, which is the chocolate piece, to get a total of 27.70 grams, equal to the unit mass, sort of like the molar mass of our s'more. Then in step 2, we're writing a balanced chemical equation to show the relationships between these. So the chemical formula of our product, of our compound, which is the completed s'more, is S2MORE. And so essentially what we do is we react together graham cracker, marshmallow, and chocolate piece, and we put those coefficients on the reactant side in front of the graham cracker and the chocolate piece, because it's going to take 2 graham crackers plus 1 marshmallow plus 2 chocolate pieces to give us 1 s'more. So the third step asks us to calculate the number of units of marshmallows, or how many marshmallows we have. And so the idea is that we would buy this big bag of marshmallows at the grocery store, but it would not tell us how many marshmallows were in there. But since we know the total weight of the whole bag of marshmallows, because that is on the bag, and we also have this value of the unit mass of the marshmallow, the grams for 1 marshmallow, then we can do a gram to mole kind of conversion, where we take the mass of the whole bag, which is 454 grams, and then 1 marshmallow has a mass of 7.10 grams. And when we do that, we round to a whole number here, just because it doesn't really make sense to have a decimal of a marshmallow. So we're saying that in our bag of marshmallows, we have 64 marshmallows. The fourth step shows you how many pieces of the other 2 reactants we need. And so for that, we're going to use our balanced chemical equation. And this is really the only new calculation that we're doing in this new unit. Is we're going to take the ratios from the balanced chemical equation, the coefficients from the balanced chemical equation, to show. So from our balanced chemical equation, and even just from what you understand about making s'mores, you know that you're going to need 2 pieces of graham cracker for every 1 marshmallow. And so we create this ratio, the fraction of 2 graham crackers for every 1 marshmallow. So if I have 64 marshmallows in my bag, then I'm going to need another 128 pieces of graham cracker. And same idea in our sort of marshmallow plus graham cracker plus chocolate equation. We have a ratio of 2 pieces of chocolate for every 1 marshmallow. So we're going to need 128 pieces of chocolate as well. So the next step is then saying, well, I can't just go to the store and say, I need 128 graham crackers. So I'm going to use the mass, the molar mass, the unit mass from the table above, to find out how many grams of graham cracker I need and also how many grams of chocolate I need. So if I need 128 graham crackers and each graham cracker is 7 grams, then I multiply those together and I get a total of 896 grams. And if I need 128 chocolate pieces and each piece of chocolate is 3.30 grams, then I need a total of 422 grams of chocolate. But again, I can't really go into the store and say, give me 896 grams of graham cracker. So if I can look on the box and figure out how many grams one box is, then I can sort of see how many boxes I need to buy. So since I need 896 grams of graham cracker and each box contains 254 grams, if I divide those, I get something around 3.5, and they're not going to let me buy 3.5 boxes of graham crackers, so I'm going to buy 4 boxes to make sure I have enough to use up all my marshmallows, because that's my goal. And then for the chocolate pieces, I need 422 grams of chocolate, and each chocolate bar is 49.5 grams. So again, I'm going to divide those to see how many bars I need. Need about 8.5 bars. So I round up by 9 bars, and that way I will have enough supplies to use up all 64 marshmallows and make 64 s'mores. So I'll see you in class. We get to make s'mores and we get to apply this analogy to real chemicals.